Day 161, Honors Physics, Photoelectric Effect, homework problem number 22. In this problem, kind of going back to the concept of power and energy, power is energy or work over time, over here on the left. Energy over time in joules per second. They give you the power here in megawatts. It's 1.8 times 10 to the 6th joules per second. Mega is 10 to the 6th. Equals the total amount of energy that will be emitted divided by the time in which it is emitted. 0.4 times 10 to the negative 6, that's micro. 10 to the negative 6 is micro seconds. So when you do the math there, the energy that's emitted totally from this laser will be in joules. You got 1.8 times 10 to the 6 joules per second for 0.4 microseconds. Gives you the total amount of energy in joules. So then up on the right here, we want to figure out the energy of each photon released. So using V equals lambda f, the velocity of a photon equals the wavelength. Nano is -9 up here, which is the traditional way to express wavelengths, 694 nanometers. Times the frequency, you get the frequency in hertz. And you want to find the energy of these photons using this equation right here, E equals hf. And using the joule version, this is kind of nice. We're leaving everything in joules here to be consistent. So what you'll have is you'll have this frequency calculated that you'll plug in here, multiply that by Planck's constant, and you will get the energy of each individual photon in this beam. And then if you want to figure out then how many photons there were, you take the total energy over here and divide by the energy in each photon. So you divide this number over here by this number over here, tells you how many photons it takes to make that total energy.